Write FMS Logo program code that draws a sphere in 3D graphics that has 36 meridians and 36 parallels. The solution receives one input data that determines the size of the sphere.
Here's an example of an FMS Logo program that draws a sphere with 36 meridians and 36 parallels. The size of the sphere is determined by the input data, size. This code uses two nested repeat loops to draw the meridians and parallels of the sphere. The forward command moves the turtle forward by the specified distance size, while the right and left commands turn the turtle by the specified angle. The final sphere command calls the sphere procedure with an argument of 50, which determines the size of the sphere. I hope this helps. Let me know if you have any questions or need further assistance.
This is not correct. I want code that works in 3D graphics, which is included with the perspective command. Try again.
I apologize for misunderstanding your request. Here's an example of an FMS Logo program that draws a sphere with 36 meridians and 36 parallels in 3D graphics using the perspective command. The size of the sphere is determined by the input data, size. This code uses the perspective command to enable 3D graphics and two nested repeat loops to draw the meridians and parallels of the sphere. The forward command moves the turtle forward by the specified distance size, while the right roll and left roll commands roll the turtle by the specified angle. The final sphere command calls the sphere procedure with an argument of 50, which determines the size of the sphere. I hope this revised code meets your needs. Let me know if you have any questions or need further assistance.
This is also not true. A straight line was drawn. When we use the perspective command, we can use new commands like up, down. Using them, we can get 3D drawings. Try again and use the up or down command this time.
I apologize for misunderstanding your request again. Here's an example of an FMS Logo program that draws a sphere with 36 meridians and 36 parallels in 3D graphics using the perspective command and the up and down commands. The size of the sphere is determined by the input data, size. This code uses the perspective command to enable 3D graphics and two nested repeat loops to draw the meridians and parallels of the sphere. The forward command moves the turtle forward by the specified distance size, while the right roll, left roll, up, and down commands roll and pitch the turtle by the specified angle. The final sphere command calls the sphere procedure with an argument of 50, which determines the size of the sphere. I hope this revised code meets your needs. Let me know if you have any questions or need further assistance.
An interesting example using up. However, no sphere is drawn. Try to make a sphere like planet Earth.
I apologize for not being able to provide you with a correct solution. Unfortunately, I am not able to generate a working FMS Logo program that draws a sphere in 3D graphics with the perspective command. I suggest consulting the FMS Logo documentation or other resources for more information on how to achieve this.
This is a sketch of my solution using classical programming in the FMS Logo programming language. We start the program by entering the procedure name, AAA. The program introduces us to its function and asks for the size of the sphere, input. This step was necessary in order to gather the data to draw the 3D sphere. To do this, I had to draw a circle of the size you gave me and look for the reference points on the circle that determine the two important sizes. The first is the distance of each parallel from the equator. It is the y-coordinate in the 3D coordinate system. The second is the radius of the corresponding circle. Please enter your name. I have printed all the collected data for you. I saved all the data in a data list. I will use that list in the final rendering of the 3D sphere. Drawing the meridian is simple and is done before drawing the parallels. Watch the following demonstration carefully. I use different sphere sizes. Let's look at the finished program code. It is somewhat more complex because I programmed the communication with the user. I have greatly shortened the program code by freeing it from all program user communication commands. Also, the collection of reference points is now completely invisible. However, it is carried out and a data list of the necessary points is created. While the 3D sphere is being drawn, that list becomes empty. The code has been optimized and instead of 36 repetitions I only entered the required 18. Of course, the mathematical technique of finding reference points and required radii is simpler, but requires better knowledge of mathematics, which elementary school students might not be able to know. However, this method is also interesting and simpler. It uses the 3D graphics capabilities of FMS Logo itself. Thanks for watching. Your clicking the like button and subscribing to my channel would greatly help me develop similar videos.